In this video, I'm going to show you how to name covalent or molecular compounds. But first, let me contrast ionic compounds. Say we have a calcium ion and a chloride ion. We know that we will always combine these at a 1:2 ratio because calcium has a +2 charge and chloride has a -1 charge. These ions will always combine in the same ratio, and the formula will always be CaCl2. The difference between ionic and covalent bonding is that in covalent bonding, we don't have exact ratios because electrons are being shared and they can be shared in different quantities. So we have to use a different system to name covalent or molecular compounds. So say we have a nitrogen and oxygen containing compound. That nitrogen and oxygen could be combining in any type of ratio. We could have NO2, N2O, just plain old NO. We could have N2O3. We could have N2O4. The nitrogen and the oxygen can combine in several different ratios. So when we name this, we can't just name it nitrogen oxide because that doesn't clearly identify which one of these compounds we're talking about. So in our name, we have to be clear as to how many nitrogens and how many oxygens are combining in that one formula. So the rules for naming covalent compounds are different. So let's go back to this writing chemical formulas flowchart. The first question we ask is there a metal present or ammonium? If the answer is no, which it will be in the case of these covalent compounds, then we ask, is this nonmetal alone? Now, just for the sake of review, this has nothing to do with naming covalent or molecular compounds, but just for the sake of review, we're going to move down and say that they are alone, and we're going to ask, is it an ion? Is this element an ion? If it's not an ion, then when we write the symbol, we just use the symbol of the element. So phosphorus would be P. The only exception to this is the diatomic elements. So hydrogen, oxygen, nitrogen, fluorine, chlorine, iodine, bromine, and astatine. If we are given one of those elements, so say oxygen, we don't write that as O. We write that as O2. So let's go back. Is it an ion? And just for the sake of review, we're going to say what happens if we have a non-metal ion. We've already gone through ions. You should know how to name and write formulas for ions, so it's no different. You use the symbol and the charge. And because these are anions, we end them in IDE, followed by ion. So if we have a chlorine ion, we don't call it a chlorine ion, we call it chloride ion. So that would be Cl with a -1. So this is what we do if the element is alone, if it's a nonmetal that's alone. But if the nonmetal isn't alone, which is the purpose of this video, then we go way over, follow that red arrow all the way over to how to name covalent or molecular compounds. And if we zoom in on those rules, what you'll see is we have two names. We have the first nonmetal and we have the second nonmetal. So these names are going to have two words, the first nonmetal and the second nonmetal. Now we are more interested in the quantity of each of these nonmetals in the compound. So the quantity is going to be very important in the name. And what we do is we use a Greek prefix to indicate the quantity. So if there's one atom of that element, we use mono. If there are two atoms of that element, we use di. If there are three, we use the prefix tri. If there are four, we use the prefix tetra. If there are five, we use penta. If there are six, we use hexa. If there are seven, we use hepta. And if there are eight, we use octa. So these are Greek prefixes to indicate the quantity of atoms of a specific element. Now the only exception to this is the first nonmetal. If there's only one of them, we don't use mono. Let's take carbon monoxide, for example. The formula is CO. We don't call carbon monoxide monocarbon monoxide. We just call it carbon monoxide. So if that first nonmetal, if there's only one of them, we don't use the prefix mono for the name. Now you'll notice that we named carbon monoxide ending with an IDE. So that same rule goes for ionic compound naming and covalent compound naming. So we have to end it in IDE, and remember the nonmetal that's first, if there's only one atom of it, we don't use mono. The rest of them we use Greek prefixes to indicate the number of atoms of a specific element in that formula. Okay, so let's try some practice problems. Now the first one is H2O. There are 2 hydrogens and 1 oxygen. Now you could just call this water. Oftentimes molecules that are really common don't go by these specific rules. They just go by their common name, like water for H2O and ammonia for NH3. But there are millions and millions of different covalent compounds, so you can't memorize the names of all of them. That's why we use this system. So we have 2 hydrogens and 1 oxygen in this water. We are going to call this dihydrogen monoxide. Now the di shows us that there are 2 hydrogens, and the mono shows us that there is 1 oxygen. So dihydrogen meaning 2 hydrogens, monoxide meaning 1 oxygen. Now we have NO2. We have 1 nitrogen and 2 oxygens. So because we don't use mono to indicate one of the first element, we're just going to call this nitrogen, and because there are 2 oxygens, we will call this dioxide. So nitrogen dioxide. Now this one's a little different. We have them combining in different ratios. Here we have 2 nitrogens, so we have dinitrogen, and we only have 1 oxygen, so this will be monoxide. So 2 nitrogens and 1 oxygen gives us dinitrogen monoxide. So just to review, we are using Greek prefixes to indicate the quantity of atoms of each specific element. So dihydrogen means 2 hydrogens, monoxide means 1 oxygen. Dioxide means 2 oxygens in the case of nitrogen dioxide. And then we have dinitrogen, which is 2 nitrogens, monoxide, which is 1 oxygen, and 2O. So I'm going to give you 3 problems here, 3 covalent compounds or 3 molecular compounds, same thing. Pause the video and try to name them on your own. So the first one is silicon and chlorine bonded together. We have 1 silicon. Now we don't use mono to show one of the first nonmetal, so we just write silicon, and there are 4 chlorides. So it would be silicon tetrachloride. Silicon tetrachloride. Remember, we show the Greek prefixes to indicate the quantities. The second one is chlorine trifluoride. Now, fluorine is one of the most misspelled elements on the periodic table, so check your work, check your spelling on how to spell the fluoride or fluorine. It's a weird spelling. You're probably not used to spelling things like it. Double check. Use your periodic table. The last one is dinitrogen tetrafluoride because we have 2 nitrogens and 4 fluorines. So dinitrogen tetrafluoride. Remember, all of these end in IDE just like we're naming any other compound. Those are the same rules as naming ionic compounds. They end in IDE. So keep that in mind when you're naming these compounds. Now this is much easier. Writing the formulas for these compounds is significantly more simple. So we have carbon dioxide. There are no prefixes in front of carbon, so we assume we have 1 carbon and 2 oxygens, carbon dioxide, so CO2. We have dinitrogen trioxide next. So dinitrogen should be N2, trioxide is O3. So our answer is N2O3. Then we have dinitrogen tetraoxide. So 2 nitrogens and 4 oxygens. So N2O4 is our answer for that formula. I'm going to give you 3 names here, and I want you to pause the video and write their formulas. So the first one is phosphorus triiodide. This one looks a little weird, and this one often gets incorrect. Students get this one incorrect. So we have 1 phosphorus and 3 iodines, so Pi3. The next one is sulfur dichloride. There is no prefix in front of the sulfur, so it's just 1 sulfur and 2 chlorines, so sulfur dichloride is SCl2. Then we have dioxygen difluoride, so O2F2. Now some advice. This video might have seemed easy And if it did, that's great. When you're naming and writing the formulas for molecular compounds, it's actually, the rules are pretty simple. Where things get difficult is when everything just starts getting mixed together. So make sure you have a plan. How are you going to determine if you have a covalent compound? Well, you look. If you have all nonmetals in your formula and there's no ammonium or polyatomic ions, if you have all nonmetals, then you're going to use this Greek prefix system. Otherwise, do not use the Greek prefix system. You don't need it for ionic compounds.